Hello everyone, today we're gonna start a playlist about chemical equilibria. In this first video we're gonna talk the reversibility of reactions. First, I'm gonna say that the main source for this video and the next video is gonna be the book Chemical Principles, written by Peter Atkins and Loretta Jones. Let's start the reversibility of reactions. Some reactions seem to proceed till they are complete. For example, we can mention the reaction between hydrogen gas and oxygen. That's one explosive reaction we have. But others seem to stop at an early stage, and we can mention the reaction between the gas nitrogen and the gas hydrogen when they are heated under pressure in the presence of a small amount of the metal osmium. We can see this reaction: nitrogen gas reacting with hydrogen, producing ammonia gas. The reaction does produce ammonia rapidly at first, but eventually the reaction seems to stop. And why they stop? Well, we're gonna use the explanation of the chemical equilibrium to justify that. So the chemical reactions tend toward a dynamic equilibrium. What does dynamic mean? It means that the forward and the reverse reactions are still taking place, but at matching rates. The rates are the same, so we cannot see more products being formed. So the mixture's composition doesn't change anymore. The reactional mixture doesn't change anymore. What actually happens when the formation of ammonia appears to stop is that the rate of the reverse reaction that we can see, that ammonia decomposing in nitrogen gas and the hydrogen gas increase as more ammonia is formed. So more ammonia produced means more ammonia decomposing. That's the reverse reaction. At equilibrium, the ammonia is decomposing as fast as it's been formed, and we express this by using these arrows. They mean that the reaction is in equilibrium, chemical equilibrium. So the nitrogen reacting with hydrogen, making ammonia. Now we have one equilibrium. That means that the mixture, the reactional mixture doesn't change its composition anymore. And we can see some graphs that explain this. We have this graph, this first graph I'm going to show you. That's the reaction to produce ammonia. We have the reactants, hydrogen gas, nitrogen gas. At first they have the highest concentration before the reaction starts, and we have no ammonia, that's the product. But when the reaction progresses, we can see that the ammonia concentration starts to rise and the concentration of the hydrogen and the nitrogen starts decreasing. But at some point they seem to not change anymore. All of the concentrations seem to be constant. They don't change anymore, as you can see. Well, why does that happen? That happens because of the chemical equilibrium. We are producing ammonia, but now we have enough ammonia to decompose and make more hydrogen and nitrogen. But at the same time, hydrogen and nitrogen are still reacting to make ammonia, but the rate of both the reaction, the forward and the reverse, are at matching rates. So we don't see changes in composition anymore. Here in graph B, that's the reaction of the decomposition of ammonia. So the ammonia is the reactant and the product is the gas hydrogen and the gas nitrogen. At first we have the highest concentration for ammonia and 0 for hydrogen and nitrogen. But with the progress of the reaction, we can see the rising of the hydrogen concentration and the nitrogen concentration. Ammonia starts decreasing, but suddenly they don't change anymore over time. Well, it happens because of the equilibrium. Hydrogen and nitrogen, that are the products of the decomposition of ammonia, start reacting, making ammonia, and the rate of both reaction, they are the same. So we don't see change in the compositions anymore. Okay, so I think these graphs, they help us to understand what equilibrium means. But it's not just because the composition of a system is not changing. It doesn't mean necessarily that we have a chemical equilibrium. For instance, if we have a glass of water and glucose, the sugar glucose, we don't see over time, we don't see the changing the compositions. The compositions doesn't change over time. But it's not because we have a chemical equilibrium, but actually there's no reaction happening there. So once again, I'm gonna repeat: to have one equilibrium situation, we need to have the condition of the reversibility of reaction. It means that if one reaction happens, the backward or the reverse reaction has to happen. That's the first thing we have to make one chemical equilibrium. And the second one is that the rates of both reactions, the forward and the reverse, they have to be the same. In this case, we have a chemical equilibrium. For this first video, that's all I want to say: the reversibility of reaction and the rate of the forward and back and the reverse reactions. The next class we're gonna talk about equilibrium and the law of mass action. Thank you for watching.